All right, we're back. Took a quick break on that last one because it got a little long, and took a little offline time to kind of kick up a new state machine and get the test put in so that we could go over how to send a request from the state machine. And I think the biggest part of it was me spending a couple minutes thinking what fit within the domain that I could actually cover. And what I've come up with is I've added a book return state machine. So when a checkout is complete and they check the book back in, the book return kicks off a process. And in this case, the book return, I've created an event called book returned. So when the book gets returned, can't find declaration, what are you talking about? Okay. When a book gets returned, it includes data like the member in the book, the checkout date, when it was originally due, and what the return date was. So we have, a history of, the book and when it was returned, when it was due. And this is going to allow us to process the return, because we want to be a good librarian. And if they return the book late, we want to fine them. Although I think almost every library has foregone fines because they would rather people read than not read. So what I've done is I'm going to put in here, the first thing that I've done is I copy the data out of the event for the state machine. I have a current state. I've only have one state of charging fine, and we'll just call this complete, as the final state, as an alternative state. We'll add that up in here. We'll put complete as one of the other states. And I've correlated the book return state machine, initializing it based off the original checkout so that we tie it back to that checkout for whatever reason. Now, the whole point of this is I want to send a request, and the request that we're going to send is if the book is late, we want to charge a fine for the book. And we want to send a request to charge that fine so that once the fine has been charged, we can progress into that complete state for this book return. So I've created I'm going to start with the request consumer that knows how to charge a fine. And this is going to be a pretty complex piece of business logic. The charge fine consumer. It consumes the charge fine message, which has a member ID and an amount, and it responds with a fine charged message, which indicates that the fine was charged to the user's account, same properties, and that's it. That's all the consumer does. So for our test that we have here within the book state machine, we are going to add that consumer to the container configuration of our unit test so that it gets configured on the test context. And we are going to, great, we're done with that. Now we have to actually initiate that request from the state machine. And we're going to do that by defining within the state machine, we have our events and we have our state. We are also going to define a request, and the request has to include 3 generic arguments. The actual type, which is book return, which is our state for our state machine. The request type, which is charge member fine. And then the response type, which is fine charged. And we're going to just call this the charge fine request. We'll just call it charge fine. We don't have to give it like the full name. And that request we're going to initialize the same way we initialize events and everything else, is we are going to say request charge fine. And we have a lot of different things that we have to pass to this as part of it. The first thing we have to pass is whenever we generate a request, from the request client, it generates a unique request ID. We have to have a place to put that request ID because we're going to use that request ID to correlate back to the state machine. So we don't use the correlation ID of the saga because if we used that by default, we could only send one request. So we don't do that in this case. We send the property within the book return that we're going to get. So in our case, we haven't added one yet. We have things like return date, due date, checked out date, but we're going to call it fine request ID. And then we can configure the request. The only thing that there really is to specify here, and there's a number of settings, you can specify them a number of different ways, but we can specify the request timeout if we want to have the request timeout. We can specify the service address if we know it. In this case, we're just going to publish, so we aren't going to specify that either. And we're going to see if it's going to work. I think it will. Now, because we don't have find request ID on our state yet, we're going to add it. It's a nullable GUID. We'll just make it a nice auto property, and that will be there. And that will give us a place to store that request ID underneath by the request itself. Let's leave it like that because I want to see if I can configure this at the minimal level. I think I can, but we're going to find out for sure. And it might just give me some default timeouts. I'm not sure. We'll find out. We'll dig into the code and look. I just want to get it working first. So let's come in here and say, let's use a conditional expression. Let's say if context.instance.return date is greater than context.instance.due date, meaning it was late, then late.request, and I'm doing this from memory, so it's always fun. Charge fine. And I think now we have the message factory, so we're going to say context.init charge member fine. I want to say this is right. New. Next, we're using the message initializer. And we're going to say all sorts of stuff. Context.instance.memberID. And let's just set the amount equal to $123.45. Sounds great. You'll never go back to the library ever again. But we also want to transition to the charging fine state. Yeah, because we're going to be charging a fine. Because of that, let's throw the else in here. Because we are going to also include the on-time handler. On-time dot transition to complete. Why is it telling me on time is weird? Oh, typo. Great. On time. Great. Awesome. So late and on time. So we have an if else. If it's late, we're going to charge them a fine. Otherwise, we're going to transition to complete. Now, the request that we're specifying in here, we're specifying the request that's here and an initializer for this. There are some other overloads to this method. I think some of them let you specify different timeouts. That's the init, let's see here, a message factory event binder. There's some other overloads that let you do some other things. I don't really remember what they are. That's really kind of not the point. The point is that I want to send the request. I have a timeout for the request, and I'm going to get a response for this. So I have my consumer in there that handles this, and I have my request. Now, I have to be able to handle the response to that event, to that request. So during charging fine, which is the state that we have, when, and in this case, I'm going to say charge fine dot completed. So I have 3 different events that are part of the request property that we added to the state machine. Completed, faulted, and timeout expired. And I can tie into any one of those events anywhere in the state machine. So for in this case, I want to say if the charging fine was completed, then we're done. I'm just going to do a simple transition to complete because everything was great. But now I'm going to add a couple other states because as it turns out, we might want to go into like a waiting on fine charge because we didn't or failed to find member. Great. Basically in a state where we have to come back and do something later. So we'll say when charge find dot faulted that we want to transition to failed to find member. And if it timed out, I mean, I guess theoretically we could do the same thing. So if it, either way, if either of those events happen, I don't actually support that. Why would I? You'd think it's the first time I'd use the state machine. I thought that I didn't support that, and I don't. When faulted, when timeout expired, transition to, great. Okay, so now I basically made it so that during charging fine, if it completes, great, we complete. If it faults or times out, we're going to just transition to a failed to find member. And that's going to go that way. Now we can go back to our state machine and see if we can send the request. So we've added our charge find consumer, so we know the consumer's there. We have the book returned. Now we want to, let me look at one of my other specs, because I want to track for some other things being produced. So I want to track that the charge member find message was consumed, because we want to verify that the consumer actually charged the fine. And then we want to verify that we actually have the fine charge event that was processed by the state machine. Well, let's see if this all happens, and if anything else, we'll just get a timeout. But we got to blow up. Oh, because we did not specify a service address. Yeah, so we didn't specify a service address for the request. So it does require a service address, and I thought that might be the case. That's kind of annoying. So this is something that I would probably inject via a settings property. But instead, I'm going to cheat, and I'm going to say, actually, I'm not going to completely cheat. I'm going to sort of cheat, but we're going to act like I didn't really cheat. I'm going to say formatter.consumer fine. What's the consumer called? Charge find consumer? And then we're going to say x.serviceAddress equals new URI, q : endpoint. Oh, I have to put the $sign. Okay, so now I'm just going to tell it that the service address is that queue. I sort of cheated to find the name of the queue. That's all right. Unable to solve I endpoint name formatter. Why was I not able to resolve endpoint name formatter? Things I forget. Book return state machine uses our state machine test fixture. Uses config in memory transport harness. Oh, because I'm using the default name formatter, so I'm just going to do config.set. Just change everything to kebab case now, because then we'll have a name formatter in the container. Hey, we got green check marks. That's good. So I did something right. We can see that in this test case, all of my endpoint names changed to be all lowercase kebab case. So that's fun and handy. So we created and we added the saga event. We created the send transport for the charge fine. We sent the command to it, which was the request. We created a send transport. We sent that back. You can actually see that we used Quartz to schedule the timeout. The request timeout expired was scheduled for the charge member fine. So the state machine, when you have a request property, it's going to use the timeout, which the default is probably 30 seconds, to schedule a timeout for that request. So you have to have a message scheduler to use the request property. So it's going to send that request. It's going to schedule the timeout. It's going to, the consumer is then going to handle it and send back to book return the fine charged response. The saga is going to use that response because it's going to correlate it by that request ID property. And it's going to come back in fine charged. And we're going to, you can see we cancel the scheduled message because the request, when it gets the response, it will then cancel the scheduled timeout as well as part of processing that. So yeah, it cleans that up nicely, handles the dealing with the scheduler, and makes sure that message won't come in. Yeah, so that's how we send a request. We did have to know the service address, which, you know, that's one part of that. Might be something cool to change later, is not to actually have to know that and to do a publish instead, but yeah. So that's how we create a request from the state machine. And you can see if we go back to the book return state machine, we have the request property, we have the charge fine. We could change the timeout. We could set the timeout, you know, equal to something shorter if we wanted to, longer. I think the default is probably 30 seconds. We can probably go look. The default is 30 seconds. Okay, so this default state machine request configurator sets to 30 seconds. Oh, yeah, so that this still supports the legacy endpoint convention stuff, which I'm not a super big thrill fan of, but some people use that. So if I had already scheduled or configured an endpoint convention for that message type, it would have pulled that service address out otherwise. And for backwards compatibility, I think that's probably why it still forces it, because what it should do is if you don't specify one, it should just publish the request like the request client does. But apparently I never put that into here, so it's something I might think about doing. Make a note of that. Yeah. So that's our request. We can certainly run that again. And we can also so now that we know that the positive test case works, and we see all the way back for the scheduling, cancel scheduled, all that fun stuff. Now we can verify in another test what happens when a fault occurs. So let me remove some unused stuff here. Some more unused stuff. Yeah, so now let me do a fault version of that. When a book is returned and fails to charge fine. So just like we had with our charge fine consumer, we're going to have our bad charge fine consumer, which is just going to throw a nasty exception. No money. And in this case, we are going to, the charge member fine will get consumed, but we definitely won't get the fine charged. We will have a fault of charge fine, charge member fine that should be consumed. And so now we have the bad charge fine who's going to handle that. Oh, this makes my test really annoying. That's why I'm really, really annoyed by this test. So because I had to code the service address, it isn't going to automatically find this consumer now. So that's really annoying. So I'm going to cheat. You're going to love this one. It's going to be fun. So when you add a consumer, you can tell it the name of an endpoint to use. And in this place, I'm going to say endpoint.name equals, what's it going to be? Kebab case formatter. .instance .consumer stop it charge fine consumer. I can't spell today apparently. So I'm going to override that endpoint name and force it onto a different endpoint, and this should work. We'll certainly find out here in a second. Actually, that repeat last run isn't going to change anything. We'll just make sure we didn't break anything, I guess. But and I can take these out because this is left over from the other test. Take it out of here too. Okay, so now I have this new test that should handle the request fault. Let's see if our new test works. So the book has failed to charge the fine, and it did. And if we look at the log, I hate that my tests always go green. I mean, red, green, refactor, whatever. I know what I'm expecting it to do, so I'm testing it the right way. I can see that the consumer threw a fault, said no money, and I can see that the saga used that processing fault charge member fine, which also canceled the scheduled message, because again, the request timeout is no longer important. One thing to think about when you're doing requests because requests require timeouts, you have to have a scheduler. Only Quartz supports cancellation of request timeout. And the reason that is because the request ID that's stored in the saga is used to cancel the request, and the transport schedulers don't support cancellation. Azure Service Bus does, so you will cancel with Azure Service Bus. It's one of the lucky ones. But all of the others, you will still get that scheduled request timeout message. So that's something you can either put into your state machine to handle, to say, hey, if you're in one of these other states, you can ignore it. Otherwise, I think it just goes away because it's a message that's correlated outside of the normal query path. But just something to be aware of, that timeout message may still show up if you're using a transport message scheduler like RabbitMQ Delayed Exchange or something like that. If you're using Quartz, it'll cancel it. And let's face it, race conditions happen. If Quartz is busy, it might send it before the cancellation is processed. So think about the fact that you might get that timeout in other states. And it should just ignore it if it's to where you don't get an error. But just recognize that when you're coding your handling of the timeout. Yeah. So all of these tests should run. We didn't really break anything. We created a new state machine for that. We're generating the request from it. An alternative approach to this is to sort of do it yourself. And that's why I showed the publish and then handling the different responses yourself. Because if you don't have a timeout and you don't want to, couple yourself to that request approach, and you want to just use like the correlation IDs that map back to your saga, you don't have to use request to do that. You can actually code all that yourself just by producing the command or publishing the command, and then correlating the events that can be produced back of that. So you can do it all with events. You don't have to use request. The nice thing about the request client is it does set the request ID. It handles all of that so that the responder doesn't know that it's calling from a saga. So it's basically able to handle any type of request. Yeah. So the other thing that I wanted to show, the last thing, is the state machine also supports the multiple request type. So fine charged is the standard response. Let's just say we have a fine overridden, and that's a new response type that we're going to add. And typically, if like a lot of libraries, if you're under 18, they don't charge fines. They're just like, what, we'd rather you read than do anything else. And so the request within the saga can also have two event types. So you can have a positive and a negative response type with the same request. And that's you just add that additional one in there. And then, if charge fine dot completed, there's a completed 2, which is about as pathetic as item 1, item 2 was on the first version of tuples for .NET. But again, it lets you handle that second response type without any big hassle. So again, that should just run because it's all within there. I didn't add that response type to my consumer. All I did was just basically specify that that's another valid response type. There is a cool thing coming in the next release of MassTransit, which is going to be 7.1 because the request client's got some cool new stuff in it. And I figured we got up to 7.07. We'll bump the minor version just to play nice. There's a new capability, and I don't think I have it in this demo yet. Let me see which NuGet packages I'm using yet. Since we're only like 25 minutes in, I'm going to go and kind of show a little bit more here. This is using MassTransit 707. Yeah, so let's look and do here. Let's do 7.0.7. And let's go out to NuGet. You can tell I go to the MassTransit NuGet package library a lot. Let's get this version. And I want to replace that with, I want to basically update everything to the latest develop version, which is 7.1 develop. I think that'll get everything. I have a weird way of updating NuGet packages, but it's because it's faster to do search and replace for all the projects for me than to go through the NuGet library manager and do it by itself. Let's verify that those are in there. 7.10 develop. Let's verify that all my unit tests still run. Because this is kind of a new feature and it's kind of cool. So I kind of want to show it because I think it's pretty neat. So I just went in here and added this fine charged, fine overridden in here. And the kind of cool thing about this is it allows the consumer to be somewhat smart now. So if I go into the charge fine consumer, I can do things like if context.isResponse accepted, and I can actually ask if that response type is accepted. And then I'm just gonna, let's just say use it, just to show that I can actually use that response type. And the reason I want to do this is because if I have down level versions of components in my system using the request client, and let's say they didn't know about the fine overridden response type, if the new consumer gets deployed and it says, oh, we overrode that fine, that request client is going to sit there and time out because it doesn't know that response type. It isn't even connected to that message type. And so when the response comes back, it's just going to sit there, it's going to time out, and it's going to assume something went wrong. Whereas in reality, everything was fine, but it just, didn't do what it was supposed to do. It didn't recognize that the consumer had completed. So by adding this capability, what happens is, and I'm going to put this in here, I'm going to go tweak my, we'll do a little debugger unit testing now, because that's always fun. And we'll say that fails to charge a fine, and we'll just run this one. Actually, we have it in our new consumer, so we're going to run this consumer, and we're going to just debug into that, because why not? We'll have a little fun. I don't think I've shown the debugger for a while, so that'll be great. And within our consumer, what MassTransit does now when it sends a request is it puts, and I'm totally going to be wrong here because I don't think the state machine does it, which is a good thing I haven't released this version yet. Give me some results. Expanding, show me the results. I don't know why I'm not getting results. It's saying I don't have any headers. Do I not have any headers? What's going on? I have a headers collection. What's in it? Yeah, I have no headers. Okay, so I need to make a note. Request client. Request client, great. State machine, bad. State machine, request activity, not sending headers. Okay. So to support somewhat of a backwards compatibility world here, if I say is response accepted and I hit F10, we're going to see that it's going to say it's accepted. And that's because the requester did not send any headers at all. So that's kind of a weird thing. And I'll fix that within the state machine. But because it's a down level client, it doesn't send any headers. We don't want to just stop sending responses to older versions of the system. So this is definitely opt-in. You don't have to use is response accepted. Nothing in MassTransit checks this. It just gives you the capability to add new responses, check if the client supports them, which once you're checking a response is accepted, anybody that's upgraded their MassTransit version from the request client perspective will be sending the additional headers that will tell you if or if not that message type is handled. And if it isn't, then you can behave accordingly. But the way this is response accepted works is it actually goes out and checks and says, hey, is this header present? Does it have values? And if it does, is the message type that is being sent, is it actually supported by any of those message types? So pretty useful. It's going to let you, and it supports polymorphism too. So if they support a down level version of it, like they support a base interface, and you create a new customized version of it, it will still send it knowing that it will deserialize on the other end. So that was one thing I did make sure that we handled. In this case, it's going to send it because there aren't any headers present, and I'll have to fix the state machine request client. If I were to do this with the other request client, let's say I went back to the book return state machine and just did this the evil way, which I think is almost hilarious. Let's just say that instead of doing that, I do a .then async context. I think I need access to like a whole bunch of stuff here for this to work, so it probably won't work. I need a bus to get the response, which I think here, I will just be, no, I can't do this because I won't have the consume context. Yeah, I would have to put this into an activity to be able to do it with the regular request client, but there's unit tests that verify it, but the request client will send a header that tells it which response types are accepted so that the consumer can then make those smart decisions. But that'll be coming in 7.1. Glad I ran into that because that would have been really annoying. So anyway, that's how to do requests from a state machine. I will take out that code that I just did before I commit this and push it up to GitHub for this episode. But thanks for joining. A couple episodes tonight. Hopefully they're useful. I think we're just about to the end of the state machine episodes. So season 2 will probably come to a close. We're looking at ideas for season 3. It might be routing slips and courier, or we might just do some intermedio type sessions. We just do some ad hoc things, like some performance testing or something like that. Just, knock out a few unrelated, topics that don't really follow into a flow like we have with the sample library. So with that, I think I'm going to sign off for tonight, and thanks for joining, and we'll catch you on the next one.